This lesson is looking at graphs that are not on a rectangular coordinate grid like you're used to. We've been using an x and a y axis pretty much your entire mathematical career. We're going to be looking at graphs now that are on a circular grid, and we call this a polar axis, or a polar graph, if you will. So first of all, let's look at some vocabulary. On a rectangular coordinate system, we have an x-axis and a y-axis. On a polar coordinate grid, we have what's called the polar axis, and the polar axis is this axis here. Everything is based off of that polar axis. When we graph things, we start with the polar axis as the initial starting place and move around the polar grid from there. The point at the center of this system is called the pole. Now when we graph things on a polar system like this, we think about it like the unit circle. So that means that this is 0 degrees, this is, or 0 radians, sorry, this is pi over 2, this is pi, this is 3 pi over 2, and everything in between. So this would be pi over 6, pi over 4, pi over 3, and so on, all the way around this polar coordinate system. Okay, so that's just a little bit of orientation. Let's just graph a couple points so you can see what it looks like to graph out on a system like this. So when we look at a polar coordinate, the way the polar coordinate is written is r comma theta. So r is the length, or the magnitude, if you will. How far out we go, I guess would be another way to say it. If we think about the unit circle, r is the hypotenuse of any right triangle inside the unit circle. So this is x, y, and r is that length, that hypotenuse. Theta is the angle from the polar axis. So that tells us how far around we go. Okay, so let's graph a couple points, and I'm going to do this in red so it'll be obvious. So let's graph the point 3 comma pi over 3. So it's a little bit strange because we actually start with the angle measure, even though it's written second in our ordered pair, if you will. We start with the angle, so the angle is pi over 3, and the r value is positive 3. So we start at the pole, start at the polar axis, and we sweep around to pi over 3, and from there we go out 3 concentric circles, like so. So that's the point 3 comma pi over 3. We're on the line pi over 3, we're 3 circles out from the pole. Okay, so I'll just label this as a reminder that that was 3 comma pi over 3. So I'm going to give you two more points to graph. I want you to give this a try. I'd like you to try and graph 1 comma pi over 2 and 0 comma pi. Pause this, go graph those, please. Okay, welcome back. I hope you actually graphed. So I'm going to graph the second point here, 1 comma pi over 2. So that means from the polar axis, I'm going to go up to pi over 2, and then from the pole, I will go out 1. That's that second point. This is 1 comma pi over 2. All right, the last point I have here, not the last point, the next point is 0 comma pi. This one's a little bit weird. So from the polar axis, I'll go over to pi, and then my r value is 0. So what that means is that's this point right there at the pole. Now how do I know that 0 pi and not 0, 0, or 0 pi over 2, or 0, 3 pi over 2? I don't, but they would all end in the same spot anyway. So this is 0 comma pi. Okay, now I want to show you something that's a little bit different. If I were to graph the point, let's say negative 2 pi over 2. So when we deal with negative r values, it's just a little bit different than how you would think about with a rectangular axis, but kind of the same. Let me see if I can explain. So if we go out pi over 2, that's vertical, so that means straight up from the pole is pi over 2. But because of that negative 2 value, instead of going up 2, we'll go down 2. So it's a little bit strange. This is the point negative 2 comma pi over 2. Can you tell me, is there another point that has the exact same location on this polar grid? I want you to pause for a moment. Is there another point you can tell me that would land in the exact same spot? Okay, so I noticed that this point, negative 2 pi over 2, is actually down on the 3 pi over 2 vector, if you will. And we're 2 units along, 2 circles out from the pole. So I can also say that this point, 2 comma 3 pi over 2, is the exact same location. They fall in the same spot on this graph. Okay, can you give me an equivalent ordered pair for 3 comma pi over 3? This one might take you a little bit longer, but I'm willing to take that time. So pause this. See if you can find an equivalent ordered pair for 3 comma pi over 3. Okay, welcome back. I hope you did it. So what I'm going to look at is the line that is pi units or 180 degrees away from pi over 3. So that would be right here. That's 180 degrees or pi radians away. And this would be 4 pi over 3. So if I say 4 pi over 3 is my theta measure, but then use negative 3 as the r value, that will put us back up to the same location that 3 comma pi over 3 is. It's a little strange to think about, but something that's good to know. Okay. Now that you've kind of got an idea how things are graphed on a polar grid, let's graph an equation. Okay, so when I look at an equation, oh, I should have copied my circles. When I look at an equation for a polar graph, it looks like this. What we're saying is, how is the r value defined? So in other words, how far out do we go from the pole every time? Well, in this case, the r value is determined by the sine of whatever angle we're looking at. The way I like to graph these is to first think about the rectangular graph y equals sine theta. I like to graph that first because that's something that's more comfortable for me and it kind of gives me a visual and some ordered pairs to go off of. So if I graph y equals sine theta, we all know what sine theta looks like. We know that the maximum value for sine is 1, the minimum negative 1. Let's see. Let's go out here to 2 pi because we know 2 pi for sine y equals sine theta is 1 period. That's how long it takes for sine to complete 1 cycle. And I know that halfway between is an important point. 3 pi over 2 is pretty important. Pi over 2 is pretty important. And I'm going to graph a couple more in there just to have some more values. I know that the sine of pi over 6 is 1/2, so I'll put pi over 6 in here. Let's see. 5 pi over 6 I also know. And let's also do 11 pi over 6. Just to have a few extra values here. So I know that the sine of 0 is 0. The sine of pi over 6 is 1/2. The sine of pi over 2 is 1. And then we're back 1/2. 0. I guess I could do 7 pi over 6 in here too to make this more 7 pi over 6 is negative 1/2, negative 1. This is getting a little crowded. But at least that gives me an idea. I've got this graph for sine theta. I've got some ordered pairs that I can now use to graph my polar graph. So let's look at the ordered pairs that I have. I have 0, 0. I have pi over 6 is the angle and 1/2 is the value. So I have 1/2 pi over 6. I also have at pi over 2, we're equal to 1. So it's 1, it's pi over 2, and so on. So I want you to use these points and graph these on a polar grid. So pause this for a moment and go graph these on your polar grid. Come right back. I'm stalling while I'm writing out these points. I hope you actually went to go do this. Okay, finally, here we go. These are the points I'm going to graph. So first thing I'm going to do is graph my polar axis. So I'm going to draw my pi over 2, 3 pi over 2 line and my 0 pi line. So here's my polar axis. And then I'm going to draw one concentric circle. And because I know there's 1, because the largest value, R value, is 1, I'm just going to draw this kind of large. And I also need a 1/2 in here, so I'm going to draw a 1/2 circle as well. Oops. Okay, so in my case, the little circle inside is 1/2, the outer circle is 1. That's not typical, but I wanted to show how this works. All right, so I'm going to start graphing these, and let's see what we can find out here. 0, 0. So that means if I look out here at 0 on the polar axis and the R value is 0, that means I'm just right here in the middle. Okay, pi over 6. I know that pi over 6 is out here. And pi over 6, my R value is 1/2. Now, how do I connect these? This is the interesting part. The way I connect these is by curving the lines. It's not a straight line. Everything is circular here. So that means that I've got a bit of a circular kind of a curve to connect these 2 points to each other. It's kind of hard to tell with such a small space. Okay, pi over 2 then, we're at 1. Also a curve to connect these. And then at 5 pi over 6, we have 1/2. So here's 5 pi over 6 approximately. Curve that. Let's see, pi, we're back at 0. So we kind of made a little circle here, if you will. Not quite circular, but oval in a way. So we kind of made a circle here, back to where we started. Now, if I continue to graph, so right here, I got one complete circle. So if I continue to graph this, so if I go to 7 pi over 6 next, 7 pi over 6 is right here. And if I graph R value of negative 1/2, that just puts me right back at this point. And then 3 pi over 2 and negative 1 puts us back at this point. And then back at this point, and then back at this point. So we completed one full cycle of this polar graph by the time we reached pi. Anything after that just continues to circle around this loop. It's cyclic, just like a sine curve is. So we know then, we can say that the period of this graph, the period of R equals sine theta is pi. This graph started to repeat itself when we got to pi. So what we can say too is that R equals sine theta intersects itself at theta equals pi. That's when that starts to repeat itself. Okay, let's try one more graph, and then we'll look at some calculus in the next video. Let's graph one more. we're going to graph r equals 2 cosine 3 theta. I'm going to do the same thing where I will actually graph the rectangular equation 2 cosine 3 theta because I want to get some ordered pairs to help me understand what this graph might look like. Okay, so the first thing I know is that this is the amplitude. This is how tall. Normally cosine fluctuates between +1 and -1, but that 2 in front will make it fluctuate between +2 and -2. This 3 in front of the theta is telling me that 3 complete cycles of cosine will be done by the time we reach 2 pi. So 3 cycles, 3 cycles of cosine from 0 to 2 pi. So when I try to graph this then, I know that since 2 pi is the normal period for cosine, I know that 1/3 of that will be 1 full cycle in this new graph. So if we go out here to 2 pi, I'm going to shrink this a lot. If this is 2 pi, then 2 pi over 3 will give us 1 complete cycle, and 4 pi over 3 will give us 1 complete cycle. So we'll have 3 complete cycles in this time frame. I'm going to increase this because that's not going to give me enough room to write. So I'm going to move this down a little bit. All right, that's good enough. All right, so let's see if we can make this a little bit easier to graph. I'm going to make this better, sorry. Oh, Notability failed me this time. Sorry to waste your time with my graph drawing here. Let's see. There we go. All right, so 2 pi is a normal cycle for cosine, but we're going to split this into thirds. This is about 2 pi over 3, and this is about 4 pi over 3, approximately. Okay, so important points then. Halfway between 0 and 2 pi over 3 is a key point because that's a key point. So half of 2 pi over 3, pi over 3, half of that, pi over 6, and halfway, pi over 2. That's 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6 if you're trying to figure it out. So that's 4 pi over 6, 5 pi over 6, 6 pi over 6, which is pi, 7 pi over 6, 8 pi over 6 is 4 pi over 3, so on. We're counting by 1/6 pi. Okay, the key points for cosine then, this is 2, this is -2, we're up here, and then at pi over 6, pi over 3, this is just a normal cosine graph, just moving a lot faster. So here, 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 and so on. Let's see if this is enough to get us a full cycle on the polar graph. So if we're looking at the ordered pairs, I'm not going to actually draw the ordered pairs this time. We're just going to use the graph above. Okay, so I'm going to draw 2 concentric circles here this time because we have an amplitude of 2. And Notability is my friend with these circles, I'll tell you. Okay, we've got the graph drawn mostly to scale. If we start with a radian of 0, r is 2. So I'm going to draw that point. I'm going to use red again. R is 2. Pi over 6 is at 0. So that means we're here for pi over 6. Drawing this. I don't want to show you. I should have shown you in the last one. This is like not only which points we're drawing, but in what order. So by drawing these arrows, it's just for me telling me That's the direction we started, and that's where we're going from here. Okay, so that pi over 3 is -2 then. Pi over 3 is 60 degrees. -2 puts that over here. Okay, interesting. I can't quite tell what this is going to look like yet, but let's keep going. Pi over 2, we're back at 0 again. Okay, let's keep going. 2 pi over 3 is at 2. So 2 pi over 3 is at 2. Let's see, 5 pi over 6 is back at 0 again. Not sure if we're done yet. Pi is -2, so pi is to the left, but -2 puts us back at 0. Looks like we may have completed a cycle, but let's just make sure. So let's just keep track. Pi was where we started. We got back to where we started. 7 pi over 6 is back at 0, so yes. Now we're just repeating ourselves. Okay, so in this case, we've got our graph, and we notice that at pi is when this thing starts to repeat itself. It's just coincidence that it happened to be the same as the last graph. Not every polar graph has a period of pi. So the period equals pi. R equals 2 cosine 3 theta intersected itself at pi. Not always, just in these two cases. Okay, that's enough for right now. In the next video, we'll start talking about some of the calculus of this, and hopefully things will start to become more clear if you're still